Let me introduce myself. I used to work at Google. I then ran my startup FutureCam. I worked as a CTO of a startup. I now work as a part-time CTO with multiple companies in a strategic role. Today I wanted to talk about an interesting technique to unify two APIs. So let's say we have two different classes, which we do in iOS. We have one called AV Capture Photo, and we have another called CM Sample Buffer. These both represent an image or a photo. They are classes that have been developed independently in different times. This is from a few years back. This is from a decade back. They have different APIs. And in some contexts, when you take a photo, you get this object from iOS. In other contexts, you get this object. Unfortunately, this is not configurable. You can't tell iOS, hey, just use this type. So now you have these two classes that you have to deal with in your program. How do you do that? One way is just to just to have an if condition everywhere you deal with a object of one of these types. Either make it like a generic type like any or object in Java, and then say if this instance of AV capture photo invoke this function, otherwise invoke that function. Or you can pass two arguments to every function. One is an AV capture photo and one is a CM sample buffer and one is nil. And each function has to check both the arguments, find out which is nil and use the other one. Obviously, this is a messy solution. If you're writing a small program, this may be okay. In fact, this may be the right solution. As with many techniques in software design, a quote unquote hacky solution may be the right solution for your code, for your level of complexity. So nothing is right and wrong. Things are right and wrong for a certain size of code. But let's assume you have a bigger code base and you don't want these if statements everywhere. How do you unify them? You unify them by picking one of the two APIs and adapting the other API to conform to the first one. So in this case, I've picked this as a primary API. And now I'm going to retrofit CM sample buffer to adopt this API, AV capture photo. So throughout my program, I can use the AV capture photo API and it will work. So that's what I'm going to do. Let me show you how I've done that. Before I show you the code, there are a couple of Swift features that you should know. One is called extensions, where you can add something to an existing data type. So if you have an image, so let's say you have an AV capture photo and you want to add a property called eSquare. It's a computed property, which means it looks like a variable, but when you access it, code gets invoked. Just syntactic sugar. Many languages have properties like Python and so on. I think C# has them. Swift has them too. And I'll be using Swift for today's discussion. And here you would write the code, right? Return width equal to height. Actually, they are floating point values, so you would do something like this. So, but whatever the implementation, now if I have a photo object, I can call it this way, as if this e-square is a predefined property of photo. Now remember, this is Apple's API, it's not our API. But extensions let you add new things to an existing class. And then you can use it just like the built-in functions of AV capture photo. So if you look at AV capture photo, it has is raw photo. So just as we can call this, which is an Apple API, we can call our API the same way once you have an extension. This is the first Swift feature you need to understand, extensions. The second Swift feature I'll talk about are protocols. Many languages, many statically typed languages have an equivalent. Java calls them interfaces. It's like a class, but it cannot have variables or fields or instance variables, whatever you call them. It cannot store any data. It has a bunch of method signatures and even method implementations, but not variables. So these are the two features we are going to use. Extensions and protocols in order to retrofit these two classes to have the same API. So with that introduction, let's look at the code. So first, I've defined a protocol called AV capture photo or CM sample buffer, right? Because this is what it means. It's one of the two. I have three properties: metadata, pixel buffer, is raw photo. And if you notice, the data type matches: is raw photo, pixel buffer, and metadata. So remember, we don't want to define a third API and retrofit both the existing classes to conform to the third API, our own API. We want to pick one of the two APIs and retrofit the other class to conform to that. So in this case, we have picked the AV capture photo API. That is why if you look at the AV capture photo class, you will find these three things. It has some other stuff, this protocol. So this is how you define protocol implementations, not just signatures. These are just signatures, right? It says that anything that adopts this protocol must have these three things. It doesn't say how they're implemented. Whereas here you have a implementation as well. CI image. And some bunch of stuff. Now, you need to retrofit things. Let's look at CM sample buffer. Here we are. I've taken the existing class and I've extended it. Look at this example. You've taken an existing class and you've extended it. Similarly, and when you extend a class, you can make it adopt a protocol. This is unlike more rigid languages like Java, where a class, when it is defined, adopts some protocols. You can't add new protocols to an existing class. You have to define your own class. But Swift is more flexible. So you can take an existing class and say, now I'm going to make this class adopt this protocol. And when you do that, you need to provide implementations of the function the protocol expects. And you do that by implementing it using the underlying CM sample buffer API. So for example, if you want to access the pixel buffer, you have to call some function. This is a C API. CM sample, C style API. It's still Swift, but it's a C style API. CM sample buffer get image buffer. So if you look at the three requirements in this protocol, you are implementing them appropriately. Once you do this, CM sample buffer has adopted this protocol. So now you can refer to CM sample buffer by means of this common protocol. Similarly, we are extending AV capture photo to conform to this protocol. And The extension doesn't have any methods because they're already implemented by iOS. Remember, we chose this to match this, the API. So there's no adaptation required in this case. And these common functions are implemented in a common way. So this implementation doesn't need to know whether it is an AV capture photo or a CM sample buffer. I was able to implement some functions in a common way like this, CI image, using these such as is raw photo, right? So if you look at this, basically what it has is, it has two layers within it. One is the low level stuff, metadata, pixel buffer, and what's the third one? Is raw photo. And then it has higher level stuff like CI image. Yeah, of course, verify full resolution. Capture timestamp, save. The implementations of these depend on the data type or the class type. If it is AV capture photo, we are using Apple's implementations. If it is CM sample buffer, we are using our own implementations, which we saw here, the implementations of the three things. But these are a higher level API within the same extension. So anyway, now that this extension is there, other functions, other classes can use it without regard to which exact type it is. Is it an AV capture photo? Is it a CM sample buffer? So for example, this is a function that processes frames. It blends them together. It's called a frame blender. You give it two images, it'll give you one output image. And it takes a buffer. It doesn't care what type of buffer it is. So you can see how this technique to adapt two classes to follow a common interface makes the rest of your code simple. So anyway, that's it for today. If you have any thoughts on this, leave a comment. Let's learn from each other. If you found this useful and would like to be notified when I post more videos of this type, subscribe to the channel. And if you want to work with me, there's a link in the description.